Instead of unwinding the patch in 64-byte chunks, why not consider using the magic value of 40 bytes? Questioned Linus Torvalds as he delved into refining a performance optimization patch during the Linux 6.5 merge window. The patch aimed to enhance the throughput and reduce latency for the checksum_partial function, widely employed within the Linux kernel for checksumming purposes. If implemented, this patch could potentially yield an impressive 8 to 9% latency improvement and up to 30% throughput improvement in specific scenarios. The checksum_partial optimization patch was recently submitted through the x86 MISC pull request. As Linus Torvalds reviewed the code, he expressed his thoughts on the mailing list. Upon reviewing the patch, I couldn't help but question why it was unrolled in 64-byte chunks when the magical value appears to be 40 bytes. Furthermore, there is mention of performing carry operations on every 32 bytes to achieve 32-byte chunk independence and increase ILP. In essence, the so-called 64-byte case is not truly unrolling by 64 bytes. It effectively entails two parallel 32-byte unrollings. In summary, we have three magic values, but the crucial one seems to be 40 bytes. I understand that 64 bytes align with the Catchalene size and have a traditional association with unrolling, but that does not make it inherently significant in this context. Consequently, wouldn't it be beneficial to adopt 40-byte chunks and consider the two overlapping 32-byte chunks as two instances of the 40-byte chunks? He appended an attachment with an untested patch, cautioning that it was purely speculative. Linus Torvalds also mentioned that he had briefly inspected the generated assembly code, which seemed to align with his expectations. However, he emphasized the lack of testing and noted that he had included a few, likely, annotations solely to enhance the readability of the generated assembly code. Acknowledging an oversight in his handwritten assembly code, Linus Torvalds added, "I noticed this when reviewing the patch again. No actual testing has taken place. Even with that, +R, the code may still contain bugs. It is simply less prone to bugs than before." He humorously concluded, "Now, I shall retreat to my cave and resume pulling stuff. I just needed a temporary diversion. Some people relax with a nice drink by the pool, but I find solace in tinkering with inline assembly." While Linus Torvalds continued to explore his version of the optimization patch, he merged the original checksum_partial patch into the codebase. His variant will undergo further discussion and scrutiny. In response to Linus Torvalds' message, AMD Linux engineer Borislav Petkov, managing the x86 MISC pull request, quipped, "And there's a third kind who relax by the pool with a nice drink, while simultaneously playing around with inline assembly."